Uh, Raj?
Yes, sir.
No,
Yes, sir.
yes, well, okay. Now it is visible. It is visible now.
Yes, sir.
Hello. Okay. So now the image classification techniques. So this is useful for suppose for enter India or for a state we have to classify different features land cover. So it takes time for digitizations manually, and therefore the machine learning techniques are there. It will create the different categories and then classifies as per the pixel values. So different techniques are there. That is called supervised and unsupervised technique. So this is science of turning RS data into meaningful categories representing surface conditions and classes and spectral patterns. So there are three categories which are used for the categorization of these satellite images. First is the spectral pattern recognitions, so which produces classifiers as a pixel based on its pattern of radiance measurement. Then spatial pattern recognitions, that is classify pixel based on relationship to surrounding pixels. Then temporal pattern like looking changes in pixels over time. So generally, we just classify the image based on our expertise and different color variations, and then after that we get to the go to the field verification for clarity of these features. So it takes more time. So for classification of larger areas in a very specific time, short period of time, then we use the image classification techniques that is called as machine learning techniques. So nowadays it is very much useful in different applications in IT field, also in artificial intelligence and deep learnings. So these are all related to this because it is a remote sensing data, so it is using the pixel value as their basic units. But in other IT line or in the deep learning and other artificial intelligence, so a lot of other things are used as a basic elements. That's why these are very much useful nowadays. But there are two ways, that is on supervised classifications and supervised classifications. So purpose of classification is for geological terrain analysis, mineral explorations, then alteration mapping, then land use, land cover. What is the land use and land cover? What is the changes in land use, land cover for urban areas or rural areas or any watershed areas or forest areas? Forest classifications are there. So based on this, machine learning, these are the two types of classification, that is unsupervised classification and supervised classification. So in unsupervised classification, so we just give the information about the system that in this area, suppose we have a study area. In this area there are maximum of 10 to 12 classes are there, so that the machine will arrange these 10 to 12 classes as per the reflectance value, as per the neighboring classes, and as per the similarity of pixel reflectance. So this is their classes, and there is the um, classification techniques. But in the supervised classifications, we have to put some basic data. Suppose for there are four rivers are there. in our study area. So just give the input by drawing some polygons for two, three polygon for river, and named as it is a river, and then different settlements, two, three settlements, then classify it is a settlement. So we just classify 10 to 15 polygons of different classes. Then based on this polygon and based of this reflectance, based on this training data, so the system classify all over the study area, to classify all over the image. So this is the supervised. So because it is called supervised, because we just supervise the analysis, but in the unsupervised, the system classify in their own way. So that's why it is unsupervised and it is supervised. So this is the technique. Suppose we just give the different classes of water, sand, forest, urban area, other areas as a training data. Then it gives the DN informations, then categorize according to the DN values. So supervised classification is better for cases where validity of classification depends on prior knowledge of the techniques, already known that type of plan to classify. So basic knowledge about the identification of features as required in the supervised classifications, and the conventional cover classes are recognized in the scene from prior knowledge. Training sites are chosen for each of these classes, and each training site's class result in cloud of points in n-dimensional measurement space representing variability of different pixels. So this is the training data. We just give some polygon of different features. Based on these features, this machine learning techniques classify all the images. So in the supervised classification, there are three type of supervised classification techniques are there. The minimum distance to mean classification, Gaussian maximum likelihood classification, parallelepiped classification. So these are based on the technique, and that the pixel will be classified based on the surrounding classes or the arithmetic mean of the reflectance of the surrounding classes, and some separating all the classes using different techniques. So each will give slightly different results. So there are no very big difference in these techniques. So some slight difference are there. The simplest method is minimum distance, in which a theoretical center point of point cloud is plotted. So minimum distance is very much useful. Gaussian maximum likelihood also useful. So these are the example. So simple parallelepiped, suppose these are the classes. So it is classify or group in different areas like this. So this is the cornfield, then is the hay, this is the urban area, this is the way water bodies. So they will classify according to this technique. Then minimum distance to mean. So in this technique, so there is a principal lines are there. So from this point, what is the distance of these classes and what is the distance of these classes? So based on the distance, so these are the closely related pixels. So it is grouped as one classes. So these are the closely pixels. So these are grouped as one classes. So these are the techniques which are used in the system-based classifications. This is the precise parallelepiped classifications. So likewise, they are grouped and classes are created. So this is the final classification, and this is the result of the minimum distance classification. This is the maximum likelihood classification. So there is a slight difference between the two classification, because it is uh, which is the water bodies are mm, some changes are there. And in the red zone, this is the classes which is red, so it is less areas in first image. It is more much more areas as compared to the maximum likelihood classes. So there are some slightly difference are there based on their classification techniques. So as per our expertise, we can choose which is the best classification. Then the unsupervised classification is the computer group all pixel according to their spectral relationships and look for natural clustering. So assume that the data is different cover classes and will be belong to some grouping. Once created, the analyst assess their utility. Suppose these are the five classes. So if we command that there are five classes, then it is classify into five classes. But if we classify it into seven classes and more than 10 classes are there, then all of the remaining three classes are merged with other seven classes. So these are some errors are there. So in the unsupervised classification, the accuracy level is less as compared to the supervised classifications. Okay, then just we will look into the practically in our RGIS. This is a satellite image. So there are a lot of classes are there. Like this is the scrubland, this is the settlement, this is the settlement area. Then this is the aquaculture pond is there. Then there is the river is there. This is the road. There's the beach, and this is the sea. So we have to first we just look into the supervised classification. After that, we classify into unsupervised classification. So we have to go to uh, image classifier tool is there in the ArcGIS. This is the image classification. So this is the image classification. Then highlight the Google image. Then this is drawing polygon for different classes. Then we have to convert it to into the signature file because it is using only in the signature file. Then after that we will classify. So these are the maximum likelihood classification, isocluster unsupervised classification. So it is a supervised classification. First is supervised, then isocluster is unsupervised classification. So first we looked into supervised classification. So this is a mangrove forest. So in the this is the training sample manager. So we can name all the classes. So this is the class. We can rename as mangrove. Then this is the river. So another class is there. So we just give small portion of the river so that according to this the all the rivers are classified. So it is a river slash creek. So creeks are there, which are like the drainage line. This is the creek. Then another features is there that is a aquaculture pond. Then this is the cropland. These are all cropland are there. So there are four classes we just draw. So we can merge all these classes into one class. It is called cropland. So this is the tool. We can merge training samples into one group. That is cropland. And these are the pond area. We can merge all these three into pond. Then rest is settlement. And this is cropland. it is C. It is a coastal sand. And this is a forest area.
सर मैंग्रोव को कैसे आइडेंटिफाई कर सकते हैं?
हाँ
मैंग्रोव एरियाज को कोस्टल
हाँ,
साइड सर।
मैंग्रोव।
हाँ, उसको कैसे आइडेंटिफाई करना है सर?
देखिए मैंग्रोव जनरली क्या होता है, मॉडफ्लैट एरिया में आता है।
ओके
तो
सर।
जिस एरिया में हाइटेड एरिया है उसमें मैंग्रोव नहीं आएगा। ये देखिए, ये थोड़ा हाइटेड एरिया है और सामने क्या होता है कि इसमें देखिए देखिए एक बैरियर है। ये दिखाई दे रहा है, इट
यस
इज
सर।
सी वॉल। अगर सी वॉल दिया गया है तो आपका जो इंटरटाइडल जो वाटर होता है ना, आपका
यस
जो हाई टाइड लो टाइड, तो पानी अंदर नहीं जा पाएगा। दैट्स वाई यहाँ पे मैंग्रोव पॉसिबल नहीं है। ये काजूरिना प्लांटेशन है। बट इस एरिया में देखिए देर इज नो बैरियर ऑफ वाटर बॉडी। तो इसमें क्या है कि इंटरटाइडल जोन है, मतलब इंटरटाइडल जोन है, अगर हुआ देन इट इज ए saline water. And saline water में generally two types of species are survive. One is mangrove, other is salt marsh. But it is not a salt marsh, because salt marsh are like in this area small trees are there. So it is a mangrove. So in the all the coastal areas mangrove is not possible. ज़्यादातर क्या होता है कि एस्टुरियन एरिया जहाँ पे रिवर जॉइन होता है, इवन कि आंध्रा, तमिलनाडु एंड केरला एंड महाराष्ट्र, in the river areas the mangroves are present. Most of the mangroves are in the west bengal. So डेल्टा फॉर्मेशन जहाँ पे होता है तो मैंग्रोव ज़्यादा आ जाता है। तो मैं एक एग्जाम्पल दिखाता हूँ। देखिए ये एस्टुरियन एरिया है, इसमें इंटरटाइडल जोन, ये सब क्रीक है। क्रीक का डेफिनेशन है जैसे ड्रेनेज generally moving from higher elevation to lower elevation, but creeks are moving from lower elevation to higher elevation because it is a lower elevation. So due to the intertidal high tide in the uh, full moon day or in a daily basis, it is go to the upper side. In the upper side, this is that these are the creeks. So in between creeks, these are the mangrove. ये सब मैंग्रोव है और ये एवरग्रीन वेजिटेशन है। आप अगर मैंग्रोव का स्ट्रक्चर देखेंगे, देखिए ये भी एक फॉरेस्ट एरिया है, काजूरिना फॉरेस्ट, एंड इट इज अ मैंग्रोव फॉरेस्ट। सो दैट इज लुक लाइक वेरी स्मूथ
सर
स्ट्रक्चर।
आई थिंक ये जो पोर्शन है आई थिंक ये प्रोसोपिस भी तो हो सकता है सर, क्योंकि ऑलरेडी यहाँ पे हमारे गुजरात के कोस्टल बेल्ट पे सेम कलर टोन में अगर सैटेलाइट इमेज में हम देखें ना सर तो उसमें थोड़ा
हाँ
बहुत
ज़्यादातर
जी सर।
ये भी होता है। फिर डिफरेंट स्पेसीज है। जब भी आप देखेंगे कि अंदर थोड़ा अलग सा स्पेसीज होता है, यहाँ पे थोड़ा अलग है, लेकिन आप भीतर कनिका में 16 टाइप ऑफ स्पीसीज है। ज़्यादातर मोर देन 16 स्पीसीज है। दिस इज द मैंग्रोव एरिया। So this is the creek. बोलो और है अभिसिनिया। अभिसिनिया स्पीसीज भी ज़्यादा आते हैं। द इट इज़ हाई सर्वाइवल रेट। अगर आप महाराष्ट्र कोस्ट में जाएंगे, हमने अभी स्टडी किया था। दिस आर द मैंग्रोव।
यस सर, इसी एरिया में थोड़ा कंफ्यूजन हुआ था क्योंकि जब हमने एक साइंटिफिक पेपर इसके फ्लेमिंगो के रिलेटेड लिखा था यहाँ पे, तो उसमें
हाँ,
आइडेंटिफाई वहाँ का एलयूएल से मुझे बनाना पड़ा, तो उसमें थोड़ा इशू था सर यहाँ पे
क्यों? इशू
कि
क्या हुआ?
मतलब सर वो आइडेंटिफाई नहीं कर पा रहे थे क्योंकि मैंग्रोव है या फिर वो प्रोसोपिस, क्योंकि एकदम बॉर्डर सी जो है पास में
नहीं,
वहाँ पे।
देखिए,
जी
आप एक तो फील्ड सर्वे तो चाहिए, सेकेंडरी चीज़ है। बट प्रिलिमिनरी अगर आप देखेंगे, क्रीक है और हाइट भी, इस ट्रीज का हाइट बहुत ज़्यादा है। अभी जो इतना स्प्रेड करता है,
हाँ सर, ये
हाइट।
दिख रहा है।
हाँ।
जी
और एक चीज़ है, आपको जो फॉल्स कलर सेटेलाइट इमेज है, उसमें आपको क्लियरली विजिबल आ जाता है। जैसे कोई भी स्पेसीज हो, अगर मैंग्रोव के साथ है, देन इन योर फॉल्स कलर स्पेसीज। आपने कभी लिस्ट पर सेटेलाइट यूज किया है? हेलो? हेलो?
यस सर, यस यूज किया है सर।
तो लिस्ट पर में तो आपने देखा होगा ना कि उसका जो विजिबिलिटी बहुत क्लियर आ जाता है।
जी
सपोज एक मैं दिखाता हूँ। देखिए यहाँ पे क्या होता है कि उड़ीसा में भी डिफरेंट डिफरेंट कोस्टल फॉरेस्ट एरिया है। सो टू आइडेंटिफाई डिफरेंट फीचर्स, तो ये मैंग्रोव एरिया है, ये दैट इज ए काजुरीना फॉरेस्ट। सो इट्स
ये क्या है सर नीचे वाला जो आप कर सर?
यस,
ये नीचे वाला सर जो?
ये वाला,
जी सर।
ये काजुरीना प्लांटेशन है।
ओके सर।
एंड इट इज ए मैंग्रोव फॉरेस्ट। सो बेसिकली आप अगर बेसमेंट देखेंगे, इसका बेस है सैंड। सो इट इज ए सैंडी एरिया। सो सैंडी एरिया में ज़्यादातर काजुरीना प्लांटेशन होता है। बट इसका बेस सैंड नहीं है। अगर किसी एरिया में सैंडी सॉइल आएगा, देन इट इज़ नॉट पॉसिबल टू ग्रो द मैंग्रोव। दैट्स वाई इट इज़ नीड्स ए मॉडी एरियाज। बिकॉज अभी देखिए इस एरिया में मैंग्रोव नहीं है, प्रीवियसली मैंग्रोव था। डिफरेंट साइक्लोन आने के बाद इस एरिया में हेवी सैंड डिपॉजिट हो गया। उसके बाद जितने भी मैंग्रोव थे वो सब मर गए। दैट्स वाई इस एरिया में मैंग्रोव नहीं है। इस एरिया में ये जो मॉडी एरिया है, इसमें मॉड क्या होता है कि जनरली आपका जो डिफरेंट रिवर से कुछ सेडिमेंट आता है, देन वो सेडिमेंट जो नॉर्थ ड्रिफ्ट होता है मानसून टाइम में, जो जितना भी करंट यहाँ से नॉर्थवर्ड ड्रिफ्ट करता है, तो वो सेडिमेंट धीरे धीरे यहाँ पर डिपॉजिट हो जाता है। तो ग्रेजुअली ये मैंग्रोव में कन्वर्ट हो जाता है। सो जब मॉड फ्लड आ जाता है तो मैंग्रोव प्रीवियसली अब 15 to 20 ईयर्स पहले इस एरिया में मैंग्रोव नहीं था, बिकॉज इट्स नॉट मॉड फ्लड एरिया। सो इट इज ग्रेजुअली इंक्रीज इन टू मैंग्रोव फॉरेस्ट because of the high deposition area, and these are the erosion area. These are the erosion area. So in the erosion area there is a sandy beach are there. When the deposition is there, then the mud flood is there. So these are all mangrove forest. These are all mangrove. So these are some of the natural mangroves, and these are some plantations are there. Some fish bone plantations are there. Uh, this is also mangrove. These are all mangrove. These are all mangrove forest, and some in the river middle side of this area. So generally, mangrove forests are found in between the 5 ppd. 5 ppd means 5 parts per thousand. If the 5 to 10 gram of saline water is present out of 1 liter of water, then the mangrove survival is possible. Otherwise, mangrove survive नहीं करेगा। सो अभी यहाँ से हमको पता चलता है कि मैंग्रोव यहाँ पे नहीं होगा, क्योंकि इसमें सलाइन वाटर नहीं है। और हमारे पास एक लेयर होता है। आप गुजरात से है ना? हेलो, हेलो।
यस सर, गॉट इट सर। ओके।
ओके, सो यू हैव नो अबाउट सम CRZ, कोस्टल रेगुलेशन जोन? ओके, okay, then we will proceed in this supervised classification. So these are the classes we have just created. Then after completing this, just a minute. Okay, and we have to save it into the signature file. Okay, then this is the classification. supervised classification. Then this is our image. Then the input signature file. Okay.
Sir,
Yes.
using this image, Google Earth images or other one.
This is a Google Earth image. We can use other satellite image.
Okay, sir.
So this is the classification. So we can get more classes so that it is clearly identify with distinct features. So this is the process. I just draw some classes. So this is the technique of supervised classification. So in this technique, the training data, these are the training data which are used for the supervised classification. So in the other platform, in the IT line, this type of supervised classifications are used using different units. So in the remote sensing, we use as a pixel as a unit. So they used different database, different unit data like different small photographs. Other aspects are there. So method is same, but the objective is different. So this is the supervised classification. Suppose we have classified only 10 classes in the supervised classification, but in the unsupervised classification, we just give the command that in this image there are only 11 classes are there. So based on this, the grouping, this system classify all the 11 classes. It may be right, or it may be some errors are there. So it is a quick process as compared to the supervised classification. So this is the technique. Um, Maybe it has some error. So supervised and unsupervised classification are different features are there. So it also classify the coastal area into three layers based on the brightness value. Like this is looks like different from these areas. That's why it created a different classes. And some this area also classes into different class, because it had some lot of boards are there in this area, and these areas there is no any board. So the pixels are different. That's why it classes into two classes. But in the supervised classes, we just give the command that this polygon is one. That's why it is classes. It is a different class. So we take some time for supervised classification for other image. So most of the time in the false color, it gives a better results because of different reflectance values. Okay, then we will proceed further. So after comparing the classification, the cluster algorithm, K-means, texture analysis, and supervised. These are the classes. In this slide, there are 15 classes automatically detected based on the unsupervised classification technique. And for newly using this classification, you can use the unsupervised classification, then know the different features. After that, we can get the supervised classification technique. And another technique is that is microwave remote sensing. So it is different used as compared to the optical remote sensing because the range of the spectrum is from 1 centimeter to 1 meter in wavelength. So previously we are using the visible range or infrared range of the spectrum from 0.5, 0.45 to 0.7 or 0.8 micrometer of different wavelength, but it is a longer wavelength remote sensing techniques in which the penetrating power of the different cloud is very high, so that it is clearly visible. There is no clouds are there in these images, and is a active remote sensing technique. A longer wavelength microwave radiation can penetrate through cloud cover, haze, dust, all about the heaviest rainfall as the longer wavelength. And that's why we are using this in the most of the time in the flood analysis, because during the flood time there is a lot of cloud cover is there and haze dust are there. So the optical range of remote sensing is not useful and, for this. So the property allows detection of microwave energy. So this is the active remote sensing. This is the passive remote sensing. The difference is, so it is depends on the sunlight and then it reflect back. But for the inactive, there is a own source of illumination is there. It has own beam. It just targets features, then reflect back, then get the information. Then we can analyze all this information. So this is the flight direction. This is the target range. So generally, it cannot be used vertically. All the transmissions and all the scatterings are not in the vertical, because if the vertically arranged, then the receiving and targeting timing is different. So there's an error. That's why it is targeting in some slant angle with antenna receive and back scatter. So this is the technique of the microwave remote sensing, and it has a different frequency bands like X band, C band, the L band, KU, K, Ka, W. These are the bands from low to high band. There's the band and wavelength. That is P band is 65 centimeter, and the satellite is AirSAR. Then L band, that is 23 centimeter. That is allos pulsar, which is uh, available in the open source. Then S band, Almaz 1, 10 centimeter. C band, radar set, SAR, MB Sentinel 1, which is also open source satellite, but reset is uh, not open source. The next band, K band, K band generally used for military domain. These are the features. Then generally in the microwave remote sensing there is a horizontal and vertical polarization. That means sometimes the sensor target the features in the horizontal way, horizontal electromagnetic propagation, then receive the information in the vertical way. So it is called the horizontal vertical polarization. That is called HB polarization. Sometimes it targeted into vertical way and then receive in horizontal. Some VH polarization and HB polarization, HH polarization. So various cross polarized techniques are there for different applications. So this is not uh, used in the optical remote sensing. It is only for radar and microwave remote sensing. But this is it's a reactive remote sensing technique. So in digital radar image, is pixel give a complex number. So it is not a digital number like all the other satellite image, which has some reflectance value, but it has a lot of information like height informations and the different times delay informations. That's why the measurement of different buildings and the earthquake measurements are very much easy as compared to other satellite. So this is the different geometry of the targeting. So this is the flight path, and this is the target to the different features, and this is the angle, look angle. This is the 90-degree. So in this swap from near range to far range, the features are collected. The different images are collected. That's why some in the hilly terrain, one part is showing different information, but other part is missing. So these are the some defects are there because it's give the in one angle. And the interferometry is in the INSAR, that is called interferometry SAR, synthetic aperture radar, that is the full form of SAR, allows accurate measurement of the radiation travel path because of its coherent. So there are two type of microwave sensors which are inbuilt in the different path of the satellites. So one, satellite two. So they give the information and reflect back. They also give the information. So after collecting the data, the height informations are collected, then used for the future use. So that is called the interferometry. So it is based on the height measurements and the shifting of different landslides and other features are there. So this is the image of the interferogram of the earthquake. Suppose so when that there is no deformations or there is no movement of the earth in the form of earthquake, then the color is like this. So these are the no earthquake zone. So when gentle changes in the uh, earth surfaces, then the image gives the this type of informations. And these are the very widely arranged colors are there in the gentle changes. When the steep changes are there, then this is the very narrow band of colors are there. So this is the steep changes. These are the earthquake zone. So these are the very steep changes in the areas, different areas, landslides areas or other areas, and it has some gentle changes. So these are also identified using this SAR technology. So most of the time, the oil spills in the sea are also detected using micro remote sensing. The tree heights or the in the crop heights and crop health assessments are also used as monitoring use in the micro remote sensing. Then flood analysis, landslides, and building heights. So these are the different high accuracy measurements are used, which is not available for in other optical remote sensing. So for this analysis, we have to use the different softwares and different techniques are there. After that, we get the result. And suppose one of the this is what is the application of the digital image processing or digital elevation model. So suppose there is a satellite data. So these are some all vegetation areas which are in the red color. So suppose we have to identify some reservoir or dam area. So what is the application of this satellite remote sensing? So in this satellite image, there are two reservoirs are there. One is looking cyan color, and another is black color. So it means we observe that this area has the cyan color reservoir is less depth, water depth. That's why it is look like the cyan color. And this water body is black. It means it has a more depth, so that the reflectance is less and the absorb of the EMR radiations are more. So now after that we also conclude that the in this reservoir the more areas have a vegetations. So generally when a reservoir is or in a dam is constructed, the lower portion has some more vegetations and uh, ground recharge is more. But in this area, the vegetation is very less and the color is very light. That means it is in the upper layer and the heighted areas, and it is in the lower areas as compared to this image. So we can also calculate the different drainage pattern using different dam, so that the different more drainage are accumulated by this dam, and this is very less drainage are accumulated, and due to the in the height area the ground recharge is more, so that the water content is less. So this is one of the conclusion. So this is the heighted information. So it is in the height areas and it is in the lower areas. So it gives the different more than 5 times more vegetation due to this uh, reservoir. So for calculating reservoir impact assessment and delineation of potential recharge areas, a lot of methodology are there. So we have to prepare some soil maps, composites for basic information, then geology maps, then list 3, list 4, other satellite data, then also rainfall and other water depth data, field data are there. So all these are field-based data, then remote sensing data, then existing topographical maps. These are all required in the preliminary level. Then the elevations, contour, dam slope, expect, flow accumulation, stream order, all associated with the dams are prepared. Then raster, vector, and attributes that are collected. Then the decisions are taken for the GIS analysis for arithmetic different conditions and the calculations, and then weightage are also given for different sites. After that, we get the reservoir impact assessment and delineations of potential recharge areas. So, what is the more recharge area? What is the less recharge area? This is one of the application in the groundwater. Likewise, urban mapping like urban sprawling. So, urban sprawling basically using the high satellite images, high resolution satellite images from different image like world view data and cartosat, cartosat data, which is zero point 0.5 to 2.5 meter resolution. The range is like this. So the 10 years interval are calculated. Then what is the spreading rate? What is the spreading direction of the urban areas and the factors for the spreading? These are also calculated, and there are a lot of fields are there for application in the remote sensing technology. So based on this different parameter of groundwater prospects are mapped in the different weightages. So whether basalt, there is the rock type basalt, there is the weightage is 1, and on weather basalt there is weightage is 2. Then valley fields there is 1, alluvial plain which is near to the coast and valley areas, and pediments that is the most hydrological region. Then residual hills, there's the weightage, the high probability of the water content in the pediments and residual hills. Then lineaments, then present or absence, there is 1 and 2. So slope is also one of the factors for the groundwater occurrence. Then we also calculate the, suppose there's a river reservoir of some area. Then when we construct a reservoir, then what is the benefit? So benefit is in the lower region there is a benefit for the different vegetation's growth and for different irrigation purpose we can use. So what is the ratio? Suppose we have 1 square kilometer of the reservoir, then the benefited area will be more than 5 times, so that it is feasible for the different economy zone. Uh, that's why the reservoirs are constructed for in the which has benefited in the lower zones. So it is a submerged area and it's a benefited area and is the watershed boundary. So a lot of drainage are accumulated in the submerged areas. Suppose some different rivers are there. So suppose submerged area like the drainage. So the reservoir area is 0.56 square kilometer or 1 square kilometer. Then the benefited area is 15.78 square kilometer. So the ratio of benefited and submerged area is 28 times. It's a very good result for this reservoir, but sometimes it is not feasible for all the landscape, and based on the different landscape there is a ratio is very less. As in the last there is submerged area is 20 square kilometer and the benefited is 13 square meter and the ratio is zero point 0.6. It's a very uh, less benefited area and is very loss is there. So more than 10 or 20 times is needed for this construction of different dams. So if there is a very less ratios, so what is the region, what is the uh, geological aspect and the soil health and the elevations are there. These are the factor like soil elevations, geology, and other man-made structures are there also. So these are the factors. So we have to analyze all these factors. Based on this, we have to choose the sites, and different remote sensing technique also helpful for choosing the best sites in for the construction of dams and all other reservoirs. Okay, for this is the topic I have to cover today. So is there any doubt? So you can ask me question.
सर लैंड यूज लैंड कवर मैपिंग के कौन सा इमेज सही रहेगा रेजोल्यूशन
Land use land cover.
मैपिंग के लिए सर ये जो हम बनाते हैं ना क्लासिफिकेशन
हाँ हाँ
इमेज एनालिसिस करते हैं उसके लिए सर
हाँ.
तो कौन सा इमेज बेस्ट रहेगा सर रेजोल्यूशन सेंटिनल लिस 4 या फिर लैंडसेट इमेज
देखिए आपका मतलब सपोज डिस्ट्रिक्ट लेवल या स्टेट लेवल कर रहे हैं, आपका एक्यूरेसी
सर
जितना अच्छा,
डिस्ट्रिक्ट लेवल डिस्ट्रिक्ट
अगर फ्रीली देखिए लेसपुर इज बेटर देन all of Sentinel and Landsat, but LIS4 is not available freely. So it is 5.8 meter resolution, and Sentinel is 10 meter. So LIS4 is best for the decentralized planning, and for urban it is not suitable. Urban mapping or on urban land use land cover, it is not suitable. And for decentralized planning for forest area mapping, list 4 is very much useful. List 4 Sentinel also very much useful for larger areas. अभी तक तो जो हमारा फ्रीली अवेलेबल है सेंटिनल इज बेस्ट, उसके बाद और ज़्यादा रिजोल्यूशन का डाटा तो मिला नहीं अभी तक. अगर मिल जाता है तो कर सकते हैं, अदरवाइज अगर स्मॉल एरियाज लोकेशन छोटा छोटा लोकेशन है तो आप गूगल अर्थ इमेज से रेक्टिफाई करके उसको ज्वाइन करके लैंड कवर कर सकते हैं. और फिर भी नहीं हुआ तो कुछ रीचेकिंग कर सकते हैं लिस्ट फोर में और सेंटिलियन डाटा में करके, तो इसमें भी हो सकता है. बट अगर एक्यूरेसी चाहिए तो जितना हाई रेजोल्यूशन डाटा है उससे आपको बेनिफिट मिलेगा.
ओके सर और दूसरा एक था सर मेरा कंफ्यूजन इसमें तो पास्ट ईयर्स के इमेजेस शायद लैंडसेट भी अवेलेबल नहीं है और सेट मतलब अवेलेबल है सर और हर एक का जैसे लैंडसेट 7 है लैंडसेट 8 तो फिर डिफरेंट टाइप के इमेजेस में कैसे वो कर सकते हैं सर उसके लिए थोड़ा इश्यूज.
हाँ, जो चेंजेस ऑफ लैंड कवर आप करना चाहते हैं.
यस सर वो मैंने बताया था ना सर पास्ट 10 ईयर का सर
हाँ तो आप
डिकेड चाहिए सर मुझे.
हाँ
लास्ट डिकेड एलयूएलसी का चाहिए था जैसे 1990 2000 2010 ऐसे 10 इयर्स के गैप में चाहिए थे सर एवरी
हाँ, तो
10
आप एक्चुअली क्या है कि सेंटिलियन डाटा आपको 2013 या 14 से मिल जाएगा.
सर
तो
14 तक अवेलेबल है सर वो जी.
हाँ 14 से मिल जाता है तो 10 ईयर्स का मिल जाता है. बका अगर आप 2004 का देखेंगे तो लैंडसेट 7 आ जाएगा, बट रिजोल्यूशन इज डिफरेंट एंड एक्यूरेसी इज लेस एज कम्पेयर टू अदर, तो उसमें थोड़ा प्रॉब्लम है. अगर इस दोनों में देखेंगे तो चेंज क्लासेस कर सकते हैं बेस्ड ऑन डिफरेंट सॉफ्टवेयर. आरजीएस में भी चेंज डिटेक्शन है, एंड गूगल अर्थ इमेज में गूगल अर्थ इंजन में भी है. तो एक्यूरेसी ज़्यादा गूगल अर्थ इंजन में नहीं है. जस्ट फॉर रिसर्च पर्पज इट इज़ ओके, बट फॉर इम्प्लीमेंटेशंस मैनुअली चेंज डिटेक्शन इज़ वेरी गुड. एंड फील्ड वेरिफिकेशन इंफॉर्मेशन अगर अवेलेबल है तो उसमें भी हम ज़्यादा इनपुट्स दे सकते हैं. चेंजेस डिटेक्शन क्यूजीएस में भी हो सकता है, लेकिन इमेज बेस्ड में ज़्यादा इतना क्लैरिटी नहीं आता है। अगर आप डिजिटाइज करके चेंज करते हैं डिजिटल फॉर्म में, सपोज वेक्टर डाटा चेंज डिटेक्शन एक होता है और रास्टर डाटा चेंज डिटेक्शंस, तो वेक्टर में ज़्यादा एक्यूरेसी आ जाता है, क्योंकि आप मैनुअली उसको इनपुट दे रहे हैं। हम्म, तो अगर मैं देखता हूँ, अगर नेक्स्ट प्रैक्टिकल क्लासेस होता है तो कैसे चेंज होता है डिफरेंट डिफरेंट टेक्निक्स में, वो बता दूंगा। और अगर कोई है तो आपका जो रीजनल सेंटर में, वो भी प्रैक्टिकल में दिखा सकते हैं, क्योंकि ये भी आपका एक प्रैक्टिकल एग्जाम में चेंज डिटेक्शन एक क्वेश्चन आता है जनरली फाइनल एग्जाम में।
जी सर, ओके सर,
ओके,
थैंक यू।
ओके, थैंक यू, गुड नाइट।